Hello, this is Praveen again. In this video, we are going to discuss a new topic. It is going to be electric potential due to a system of charges. In this case, we are considering a point P. Now this point P is surrounded by multiple charges. Now let's imagine there is this charge Q1, Q2, Q3, and we keep going. We can keep going on with multiple charges. So let me show you. So there are infinite charges like that exist. Okay, so let's say we go on up to Qn. Now each of this charge is at different distance from this point P. The first charge is at R1, the second charge is at a distance of R2, the third charge is R3, and so on. Obviously this charge would be a distance of Rn. We are interested in finding the electric potential. At P. When we do that, while it is a system of charges, we can arrive at the total summation only if we are able to calculate the electric potential due to each point charge. Now as a result of that, I will do this for Q1 first. So let's call that as V1. It's given by, we know the formula for that, 1 by 4 pi epsilon naught into the charge itself by the distance. Similarly, we could do this for all the point charges and the electric potential at P. That way we could calculate the total electric potential. At P. So if I say the total electric potential is V, it is made up of V1, V2, V3 and etc. goes up to Vn. Now this is nothing but V equals, we are going to have multiple terms, but 1 by 4 pi epsilon naught is going to be common term in each of them, and the summation is going to look like Q1 by R1 plus Q2 by R2. It goes on up to Qn by Rn. Can we express this as a summation? Yes. So V equals 1 by 4 pi epsilon naught sigma I equal to 1 to n. It goes for Qi by Ri. This is the expression we are looking for. Can we write this as a vector? Because right now this is in absolute magnitude form. Now let me try to write this as a vector. So if it's a vector, it is going to be V equals 1 by 4 pi epsilon naught. Mind you, V is not a vector. I'm writing the internal components, whatever that is inside, as a vector. Now how do we do that? Sigma I equal to 1 to n Qi. Now Ri is this distance. Now each of this distance I can write it as a vector. How do we write that as a vector? R minus Ri, modulus of that, R minus Ri vector. So that will give me the position vector. What is R? So R is nothing but Let's look at this. We want the distance of all the charges from P. Let's call it R1, R2, R3, etc. We don't know this distance. Now what we are rather looking at is, I'm taking this point origin here. Now from this origin I'm drawing vectors. So this is R1 because I've drawn this to R1 to P1. This is R1 because I've drawn this to Q1, Q2. The distance is, the vector is R2. Q3 is, let's vector. Q3 is R3 vector. Now this is R vector. So R vector minus Ri vector. That will be position vector.